All right, welcome back, class. So this is 9.4b, where we're doing the second part, or second day of solving exponential and logarithmic equations. We're starting with some review, so I'm going to do a couple of these as a refresher. So let's look here. This first one, evaluate log base 4 of 8 equals x. So we can make it an exponential function, so it's 4 to the x equals 8. Now we can take the log of both sides because that's the inverse of our exponential function. So that on the left, the property says this x can now come out front, so it's log of 4 equals, or x times log of 4 equals log of 8. And then finally, since this is multiplying, we can divide both sides by log of 4. And we get x equals log of 8 divided by log of 4. And I already have approximated this. You can check on your calculator. It's approximately 1.5. Whoops. 5. And why don't I just show as a refresher. So we have log of 8 divided by log of 4. So that's, well, 1.5. It is 1.5. Another one I can do here then, I'll do this, where we can do our common log. So that property was log base b of x becomes, this is now on top where it's log of x over log of b, and that's what whatever we're solving for, so we can do that right here, so that it's log of 4 over log of 12, and then we can approximate that, which I have done that as well. You can check it, it's 0.56, and that's just showing two different ways to evaluate, so why don't you try one of each below. Next property, for b is greater than 0 and not equal to 1, if we have the same base, like we do, base of b, then our exponents must be equal. So we do not yet have the same base, but 2 and 32 are related. 2 to the 5th is going to be what 32 is. This is equivalent to 32. So we can manipulate this base to be 2 to the power of 5 times x minus 1. Now we have a common base of 2, so we can set 4x equal to 5 times x minus 1 and solve for x. So we can use the distributive property, so we have 4x equals 5x minus 5. We're solving for x, so we're going to divide both sides by, or subtract both sides by 5x, so we have negative x equals negative 5. Next we want to divide by negative 1, so we have x equals positive 5. So that's how we can solve there with a common base. This lesson is relatively short compared to the last one because it's really review. This was in 9.4a, this one here, so I'm just going to move on to this next one. Again, inverse operation, so we're going to subtract 3 from both sides. We have 5 to the x plus 2 equals 22. Now we're going to want to take the inverse of exponential. This is an exponent, so we want to take the log of both sides. So it's log of 5 to the x plus 2 equals log of 22. Our property then says that this can come out front. This is the quantity, x plus 2. So it's x plus 2 times log of 5 equals log of 22. So since this is a product here, we're trying to get x by itself. We're going to want to divide both sides by log of 5. This will simplify because anything divided by itself is 1. So then we're left with x plus 2 equals log of 22 divided by log of 5. Now, our next inverse operation to get x by itself would be to subtract 2 from both sides. Therefore, x equals log of 22 divided by log of 5 minus 2. These are not like terms, so this is simplified down. this would be our exact answer. If you were to approximate it, you can do that. You would do log of 22 divided by log of 5. Then this you would subtract from 2. So it's approximately, this is approximately negative 0.08. Reiterating, this is my exact. This is exactly my answer. This is approximately my answer. Solving logarithmic equations. So my inverse of log then. If the inverse of exponent up here is log, the inverses of log will be exponent. So you can exponentiate both sides. Otherwise, we can notice in this case, we don't need to exponentiate each side because we have a same base of 4 and they're both logs, so these are the same, just like up here. Therefore, what's on the inside? X must equal y. So we can set x plus 3 equal to 8x plus 17 and solve for x. So I'm going to subtract x from both sides. So 3 equals 7x plus 17. Subtract 17 from both sides, or add a negative 17. So we have negative 14 equals 7x divided by 7. Therefore, x equals negative 2. And let's check it. Let's plug it in. Let's substitute it. Log of 4 of negative 2 plus 3 equals log of 4. Log base 4 of 8x plus where x is negative 2 plus 17. So this side, we're verifying that the equation is balanced. Log of 4 equal log base 4 of 1 equals log base 4 of 8 times negative 2 is negative 16 plus 17 is 1. So that verified it, implying that x equals negative 2 to make this equation balanced. We're solving for x. Exponentiate each side. So this is where we're going to want to take whatever our base is, our common base, to both sides. So on the left here, it's a common base of 4. So we're going to take 4 to the power of that side and 4 to the power of that side. Again, if it's log, our other property is going to be b to the power of log of b. We'll simplify to just 1. So this simplifies to 1 times x plus 3. And this is 4 to the power of 2, which is 16. Now we can solve for x. Therefore, x equals 13. And you could check that then. We want to isolate, so we're going to divide both sides by 4 first. So then we have log base 3 of 3x equals 5. The other way we could do this is doing 3 to the power of 5. We learned this at the beginning of the week, equals 3x. So then we're isolating for x, divide by 3. We could use our quotient rule where we have a same base and subtract our exponents. So this is equivalent to 3 to the 4th power, because that's an exponent of 1 equals x. 3 to the 4th is 81, so x equals 81. Or you could take 3 to the 5th, which is 243, divided by 3, and get 81 the same way. So your properties of exponents are popping up a lot in this unit. That's actually the end of it. So that was a faster version of yesterday's lesson. If you have any questions, that's okay. Make sure to take your time and understand these properties, because they will help you solve and find these solutions. And make sure to occasionally check by plugging back in, just to be clear that you get the same answer out and verifying that the equation is balanced. Otherwise, that's all I had for today, so thanks for listening. That's probably the last unit I'll be doing. It's a little somber, but I hope you enjoyed listening to me, or at least having me in class. So thank you. Bye.